smarter memory for giant AI models. Running massive mixture of experts models on consumer hardware has long required creative engineering, and new experimental work demonstrates that dynamic expert allocation can meaningfully extend what's possible. A developer testing Qwen 3 235B and GLM 4.6 on an M2 Ultra with 192 GB of unified memory found that not all experts are created equal. First and last layers activate a more diverse set of experts, while middle layers show predictable patterns that benefit from aggressive caching. The approach borrows from Cerebrus's REAP method: store frequently used experts in fast memory, evict the rest to slower storage, and prefetch speculatively. With 96 out of 128 experts cached and some layers loaded fully, the developer achieved 14.6 tokens per second on the 6-bit Qwen 3 235B, roughly half the speed of a 4-bit version that fits entirely in unified memory, but for a model that otherwise wouldn't run at all. The hit rate data is illuminating. With a warm cache covering aggregated frequently used experts, short prompts and 512 token generations saw cache hits exceeding 90% at a cache size of just 75% of the model. Community discussion highlighted several optimization vectors, including look-ahead techniques that pass activations from layer L to the expert router of layer L+1, enabling speculative prefetching a few layers in advance. Others suggested tracking expert usage with floating average counters, effectively building a ranked cache that adapts to workload patterns. The consensus: for single query, personal use scenarios, dynamic allocation is definitely feasible, though production systems requiring high throughput will likely need most experts resident anyway. Section: Emoji Smuggling and Agent Security Risks. The proliferation of local AI agents with tool access has opened a new attack surface that many deployments simply ignore. A detailed demonstration of emoji smuggling shows how malicious instructions can be encoded in tokens that humans overlook, like certain Unicode characters or emoji sequences, but that LLMs interpret as commands. The technique extends to indirect injection, where a local model summarizing a web page or email executes hidden prompts embedded in the content. For anyone running agents with function calling capabilities in Llama 3 or Mistral, the question becomes pointed: do you sanitize inputs or just trust the model? The discussion surfaced a comprehensive defensive architecture from one practitioner: normalize all inputs to NFKC, strip zero-width and bidirectional characters, map or drop emojis, remove HTML and scripts, and cap token counts from fetched pages. On the output side, constrain decoding to tool-only JSON with grammar enforcement, allow listed tool names, and strict schema validation for parameters. A gateway layer using Kong or Envoy with OPA or Cerbos checks user, tool, and arguments before any action executes. For database access, read-only credentials over curated views or stored procedures, never raw SQL. A two-stage guard running LlamaGuard or rebuff scores for injection. If suspicious, the system forces summarize as data mode and disables tools for that turn. The core philosophy distills to a single line: don't trust the model, enforce rules outside it. Some community members pushed back on the complexity, arguing that proper API design and RDBMS permissions should suffice, but the counterpoint, defense in depth, carried weight among security-minded practitioners. RAG strategies for enterprise codebases. Building retrieval-augmented generation pipelines for large codebases requires careful thought about what exactly to embed. A developer tackling 500K+ line of code repositories for engineering organizations posed the technical question: should you embed source code directly via AST parsing, generate documentation first with LLMs like DeepWiki and embed that, or run a hybrid approach with intelligent query routing? The use cases demand bidirectional tracing between design decisions, RFCs, ADRs, and implementation, plus conflict detection, architectural search, implementation drift analysis, and security audits. The emerging consensus favors hybrid approaches with nuance. One practitioner recommended multi-vector embeddings. When walking the AST, store code in a code vector and the doc block in a text vector, using a vector database that supports this structure. Specification documentation goes in a separate collection. The Holy Grail, per discussion, combines vector and graph databases. Vectors provide semantic similarity, Graphs expose deeper relationships through explicit connections. Agentic RAG architectures that orchestrate multiple retrieval strategies based on query type appear most promising. Success depends heavily on metadata quality for filtering and well-written doc blocks for language understanding. For workflows like tracing an RFC to implementation files, tight PRDs that reference RFCs explicitly, with requirements referenced in code comments, pay dividends. Open-source research tools gain ground. The gap between commercial AI research tools and open-source alternatives continues to narrow. SurfSense, positioning itself as an open-source notebook LM or Perplexity alternative, now supports over 100 LLMs, including local OLAMA and VLLM setups, 6,000-plus embedding models, and 50-plus file extensions via Dockling integration. The tool connects to 15-plus external sources, including CRXNG, Tavily, Slack, Linear, Jira, Confluence, Gmail, Notion, YouTube, GitHub, Discord, and Airtable. Podcast generation works with local TTS providers like Kokoro. Role-based access control enables team deployments, and a cross-browser extension captures dynamic web pages, including authenticated content. For those seeking offline operation, a separate project built an AI chat application that automatically pulls Wikipedia articles for factual answers using OLAMA locally. Discussion quickly turned to the need for a universal KiwiX API endpoint that works with tool calls from any inference engine, which would unlock far more local reference possibilities than just Wikipedia. Early experiments with ZimMCP Server and LLM tools KiwiX show promise, though smaller models like Qwen 3 1.6b struggle with reliable tool calls without fine-tuning. The model understands that Zim files exist, but doesn't understand that they're a replacement for their concept of web search, a problem potentially solvable by simply renaming the tool call. Agent swarms and coding workflows. Multi-agent architectures for software development continue to mature. DevCrew S1, a 20-agent swarm from GSA TTS, orchestrates specialized agents including a blueprint writer, ADR ASR writers, back-end engineer, front-end engineer, code reviewer, QA tester, security auditor, system architect, and UX UI designer. The framework aims to bootstrap full-stack software projects from a single design document in plain language, producing documented, executable code with tests. The specification supports implementation via Claude Code, Amazon Strands, or Crew AI, with community interest in local OLAMA implementations. Meanwhile, Amazon's Nova 2 Lite models on Bedrock now integrate directly with Claude Code via configuration-based routing. A sample configuration demonstrates routing preferences that direct code understanding tasks to Claude Sonnet 4.5, while routing code generation to Nova 2 Lite as the default. This mix-and-match approach optimizes cost and capability across different coding scenarios. For Claude Pro subscribers debating upgrades, the practical advice from heavy users: Pro works for casual usage, but hitting session limits 2 to 3 times daily is common. Max at $100 a month suits serious, frequent use. Budget-conscious developers report success combining free ChatGPT for analysis with Claude Pro for implementation, using the enforced pauses to actually read and understand the generated changes. DeepSeek pushes self-verifiable math reasoning. DeepSeek has released DeepSeek Math v2, a model built on DeepSeek v3.2x base that represents a significant step towards self-verifiable mathematical reasoning. The motivation is clear. While scaling reasoning with reinforcement learning that rewards correct final answers has pushed LLMs from poor performance to saturating competitions like AIME and HMMT within a year, this approach has fundamental limitations. Correct answers don't guarantee correct reasoning, and many mathematical tasks like theorem proving require rigorous step-by-step derivation rather than numerical answers. The technical approach trains an accurate, faithful LLM-based verifier for theorem proving, then uses that verifier as a reward model for a proof generator. Crucially, the generator is incentivized to identify and resolve issues in its own proofs before finalizing them. To maintain the generation verification gap as the generator improves, the team scales verification compute to automatically label new hard-to-verify proofs, creating training data to further improve the verifier. Results are striking. Gold-level scores on IMO 2025 and CMO 2024 and a near-perfect 1/18/120 on Putnam 2024 with scaled test-time compute. The team frames this as validation that self-verifiable mathematical reasoning is a feasible research direction that may help develop more capable mathematical AI systems. Semantic compression as programming philosophy. A resurfaced 2014 essay by Jonathan Blow offers timeless guidance for code organization that resonates with current AI-assisted development practices. The piece advocates compression-oriented programming, treating code like a dictionary compressor that minimizes semantic redundancy. The critique of traditional object-oriented programming is sharp. The stereotypical approach of identifying nouns, creating classes, and building inheritance hierarchies before any working code exists leads to prematurely reusable code that solves problems the programmer doesn't actually have yet. The core methodology, like a good compressor, I don't reuse anything until I have at least 2 instances of it occurring. The mantra becomes, make your code usable before you try to make it reusable. Waiting for at least 2 examples saves time thinking about reuse until needed, provides real examples of what code must do, and prevents mistakes from writing code with only theoretical requirements. The essay details a shared stack frame technique for compression, pulling variables that appear across functions into a shared structure, enabling what could be separate functions to share state. The benefits compound. Code becomes easier to read, minimal parsing, semantics mirror the problem domain, easier to maintain, identical operations share paths, and easier to extend, similar operations compose naturally. As Blow notes, traditional methodologies claim to do these things in an abstract fashion, but always fail to achieve them because the hard part of code is getting the details right. Emacs as complete desktop environment. In the spirit of minimalism pushed to its logical extreme, one developer documented running Emacs as their entire window manager inside a minimal Ubuntu VM. The setup: install only Xinit and Emacs on a server flavor Ubuntu, create an .xinit.rc containing just Emacs, and the result is a full-screen Emacs session that handles window splitting, program launching, file editing, and even web browsing via EWW, all without touching a mouse. For pages requiring JavaScript, a key binding launches a graphical browser that overlays Emacs temporarily. The practical value extends beyond novelty. A configuration function organizes multiple applications, Stack Overflow interface, RSS feeds, Twitter, into a registered window layout recallable with a single keystroke. For those needing occasional graphical applications, Rat Poison emerges as the recommended lightweight window manager companion, though its default key conflicts with Emacs transpose. The solution: rebind Rat Poison to use an otherwise useless key. The broader point resonates with developers seeking distraction-free environments. Window managers accumulate features until they're as bloated as their predecessors. Sometimes the solution is to skip them entirely. Trading stocks: an 8-month experiment. A systematic backtest gave 5 LLMs, GPT-5, Claude Sonnet 4.5, Gemini 2.5 Pro, Grok 4, and DeepSeek, $100K in paper money each, and asked them to maximize returns over 8 months from February to October 2025. The environment provided access to market data, news APIs, and company financials, all time-filtered, so agents saw only information available on each specific trading day. Models ran only within their training cutoff dates to prevent memorization of market outcomes. Grok performed best, with DeepSeek close behind. Almost all models built tech-heavy portfolios that benefited from summer 2025 growth. Gemini came in last, being the only one with significant non-tech holdings. The team acknowledges clear limitations. Backtests don't simulate the competitive, adversarial nature of real markets, nor do they account for slippage or volume constraints. Potential data leakage from the future and overfitting to historic data remain risks. The stated goal isn't to prove agents beat the market, but to use markets as a north star of real-world grounded data to evaluate models and improve workflows. Financial markets offer both quantitative and qualitative evaluation dimensions. And since reasoning is text-based, researchers can examine decision-making processes to distinguish memorization from genuine analysis. Video pixels aren't always square. A seemingly simple web development task, preventing page layout shifts when embedding videos, revealed a quirk that most developers never encounter. Not all video pixels are square. When QuickTime Player reports a resolution like 1920x1080, 1350x1080, the parenthetical reveals the non-square pixel aspect ratio. Simply extracting dimensions from video metadata doesn't always yield accurate display dimensions. The fix requires tools that understand pixel aspect ratio. The media info library shows promise but suffers from rounding issues. The reliable solution, call ffprobe, which ships with FFmpeg, and parse its output for the correct display dimensions. While rectangular pixels are uncommon in modern video, they appear regularly in DVDs and SD-DVB content. For anyone building video-aware applications, the lesson is clear. Validate assumptions about pixel geometry, especially when working with archival or broadcast origin content. Measuring agent influence in AI workflows. As agentic AI workflows proliferate, understanding which agents actually matter for a given output becomes critical for observability, failure detection, and efficient guardrail placement. A new research paper introduces KIR, Counterfactual-Based Agent Influence Ranker, the first method for assessing influence levels of individual agents in multi-agent LLM systems. The motivation is practical. Applying AI guardrails to every LLM call can triple system inference time. Knowing which agents matter most enables targeted monitoring. KR operates in two phases. The offline phase systematically perturbs each agent's output using an LLM to generate maximally different but valid responses, then measures effects on the final output and workflow structure. The influence score combines output change metrics with workflow change, measured via Levenshtein distance on activation sequences. The online phase matches new queries to representative queries from the offline analysis and returns pre-computed rankings with negligible latency. Evaluation on AWZoo, a dataset of 30 use cases across sequential, LLM router, and functional architectures, showed CARE achieving 82% precision for identifying top 3 influential agents, compared to 29 to 33% for graph theory baselines. In a guardrail application, applying protection only to KIR-identified top agents reduced latency by 27%, with only a 0.3% drop in harmful content detection. The researchers note limitations. Evaluation used only one LLM provider. The perturbation technique handles only text-based agents, and agents not activated during representative queries cannot be ranked. Claude now fine-tunes models autonomously. Hugging Face has released a capability that lets Claude and other coding agents fine-tune language models end-to-end, from job submission through monitoring to hub deployment. This isn't script generation. Claude actually submits jobs to cloud GPUs, selects appropriate hardware, T4 small for 0.6B models, scaling up for larger ones, configures training with Tracheo monitoring, and reports job IDs and estimated costs. A natural language command like fine-tune Qwen 3 0.6B on the dataset OpenR1 Codeforces COTS triggers the entire workflow. The skill supports production training methods, supervised fine-tuning SFT, direct preference optimization DPO, and reinforcement learning with verifiable rewards. For models larger than 3B parameters, the agent automatically applies LoRA to reduce memory requirements. Dataset validation catches format errors before GPU time is spent, crucial when a 50-cent test run can prevent a $30 failed production job. The complete example workflow, from natural language description through GPU selection, authentication, and model persistence, costs approximately 30 cents. GGUF conversion for local deployment with llama.cpp and tools like LM Studio or Llama is supported. Requirements include a Hugging Face Pro or Enterprise plan and a compatible coding agent, Claude Code, OpenAI Codex, or Gemini CLI, with Cursor and Windsurf integrations coming. Bridging TTS providers to OpenWebUI. The official LLM bridge for Gemini TTS frequently fails on the V1 audio/speech endpoint that OpenWebUI requires, prompting a developer to build a lightweight Docker proxy that handles the full conversion chain. OpenAI format to Gemini API to FFmpeg audio conversion to binary output. Configuration is straightforward. Point OpenWebUI's TTS settings at the proxy, use any API key value, and select Gemini voices like Core or Charon. Community discussion confirms Gemini TTS quality exceeds alternatives. Though free tier rate limits hit quickly, even two-turn conversations trigger throttling. For those seeking local TTS, the conversation pivoted to alternatives. Kokoro Fast API remains the best free option for local inference, though it excels primarily in English. A community member rapidly prototyped a Vibe Voice 0.5b real-time wrapper using Claude Opus 4.5 via anti-gravity, achieving a functional OpenAI-compatible API in just 4 chat iterations, using the Gemini TTS wrapper as a baseline reference. The resulting repo demonstrates the speed at which competent tooling can now be assembled by combining capable models with clear architectural templates. Zero Config AI Service Discovery. A UC Santa Cruz master's student has proposed Saturn, a zero configuration protocol for AI services that applies the printer discovery model to LLMs. The concept: anyone should be able to join a Wi-Fi network and access LLMs without passwords or IP configuration, just as they can print. Saturn uses MDNS lookups for step local to discover services, with simple command line tools for announcing and browsing. An OpenWebUI function implementation demonstrates the integration. A Saturn server with an open router key returns every model available on the service, accessible from OpenWebUI without ever entering API credentials directly. The project addresses a gap in current tooling. While OpenWebUI defaults to localhost 1434 for Ollama discovery, Saturn extends this to any AI service on the network, including Ollama servers on more powerful machines elsewhere in the house. Community pushback noted that Docker, OpenWebUI, and RBAC already solve the Share My LLM with Guests use case, but supporters emphasize Saturn's value as a discovery layer for applications. Photo apps needing caption generation or code editors wanting completions shouldn't require setting screens for pasting IP addresses. Subject-consistent video generation advances. ByteDance has released BindWeave, a unified framework for subject-consistent video generation that handles both single and multi-subject prompts. The architecture couples a pre-trained multimodal large language model with a diffusion transformer, achieving cross-modal integration via entity grounding and representation alignment. The MLLM parses complex prompts and produces subject-aware hidden states that condition the DIT for high-fidelity generation. On the OpenS2V eval benchmark, BindWeave achieves a total score of 57.61%, with particularly strong showings in motion smoothness 95.90% and GME score 67.79%. The model edges out Vase 14B 57.55% and Phantom 14B 56.77%, while outperforming commercial systems like Kling 1.6 56.23% and Vidu 2.0 51.95%. Face similarity scores of 53.71% indicate room for improvement in character consistency, but the overall performance demonstrates competitive capabilities against both open source and commercial alternatives. Style-to-photo conversion via LoRA. A specialized LoRA called Anything to Real, built on the Qwen Edit 2509 model, aims to transform any art style, illustrations, anime, cartoons, paintings, into photorealistic images while preserving original composition. The alpha release uses a prompt template of change the picture 1 to realistic photograph, description of your image, at strength 0.5, 0.9. Adding detailed descriptions improves transformation quality, though the model functions even with minimal prompting. The project acknowledges its alpha status openly. Training used a limited data set, and the creator seeks community feedback to build toward a robust, generalized solution. A running hub workflow demonstrates practical implementation with 21 nodes running on RTX 4090 hardware. For artists wanting to visualize characters in realistic form, or anyone curious about style transformation, this represents an accessible entry point to image editing with modern diffusion architectures. RWKV offers alternative to transformer memory. A developer reports that switching from Llama 3 to RWKV7 solved persistent context amnesia issues in a personal assistant application. The architecture combines RWKV7 with a vector database and auto-ingestion script. Dropping a 50-page PDF into a folder triggers instant indexing, and queries weeks later recall exact details without rereading files. The key advantage: RWKV's hidden state is a tiny tensor, a few megabytes, that can be snapshotted and reloaded instantly, enabling what the developer describes as waking up versus booting up. The RNN architecture's efficiency on CPU makes it particularly attractive for always-on daemons. Community interest was immediate, with requests for the repository. Testing confirms that the 4B RWKV model handles conversation better than Qwen 4B for some users, with notably less preachiness than Llama or Qwen. Since it runs locally, users become their own safety team. The project, dubbed Ghost, represents the kind of personal tool that emerges when individual developers optimize for their own workflows rather than general-purpose benchmarks. Video model repackaging and Docker tools. Comfy.org has released repackaged versions of Hunyuan Video 1.5, making the video generation model more accessible for integration with ComfyUI workflows. The repackaging effort addresses the practical friction of working with large video models in node-based generation pipelines. On the infrastructure side, DocMate offers a terminal-based Docker container manager built in Go that provides live stats, single key press container management, and log viewing without leaving the terminal. Recent updates improved container load time from 20 to 30 seconds to 2 seconds by switching to bulk operations. The tool supports automated installation with SHA-256 checksum verification, addressing a perennial developer need. Think HTOP, but for Docker. Both projects reflect the ongoing work of making powerful tools more accessible through better packaging and simpler interfaces.